Hello everyone, and welcome to my channel. This is an educational channel, and we take deep dives into great theories of everything, all-encompassing theories, cosmologies, and try to delve into how to best use them in your own life to shift your paradigm, to awaken to 5D consciousness, and to form a holistic worldview. Today is our 519th video that we've done on Dewey B. Larson and his reciprocal system of theory. And the reciprocal system, also known as the universe of motion, is a theory of everything that Larson started working on back in about 1930 when he had some epiphanies working as a chemical engineer out in Portland. And he took many, many years to develop his ideas in an inductive manner. And then around 1959, he proposed his two fundamental postulates about how he believed the universe operated. And from there, through a process of deduction, he derived a theoretical universe, what Larson's universe would look like if his postulates were correct. And then he compares his theoretical universe with the measured empirical universe of modern science that they have compiled in many of their scientific tables. He does that here in this study called Basic Properties of Matter that we're reading from today. We are on chapter 26, which is called Atom Building. Now, Larson does most of the work in his first postulate. The universe is composed entirely of one component, motion. Not matter, not energy, not force, or anything else, but motion. And in particular, what he calls scalar motion. It's a motion with a magnitude, but no specific direction, that you can model using a balloon that you put dots on. If you blow up the balloon, all the dots will be moving away from each other. If you suck in the balloon, all the dots will be moving toward each other. They won't be moving in any specific direction. Each dot will be moving toward or away from each other dot. So every dot will be moving in every direction. No specific directions. This is a scalar motion. The outward motion Larson calls the progression. The inward motion he refers to as gravitation. And the progression is really the source of everything, but in order for it to manifest, it has to be reversed and turned into gravitation. And so Larson says that the universe is composed entirely of one component, motion, existing in 3 dimensions, in discrete units, and with 2 reciprocal aspects, space and time. Okay, so the universe is made out of motion. Motion is the relationship between space and time. You can see that in something elementary motion called speed. Speed is, the bicycle is moving at 10 miles per hour. 10 miles of space in 1 hour of time. That is speed, space over time. But Larson applies that to all of our scientific phenomena. And like matter, like energy, like force, like acceleration, pressure, electric charge, electric current, these are all forms of motion. And they all can be described exclusively in space-time terms, as fractions, with space or time as the numerator, and time or space as the denominator. with exponents. So, for example, matter is time to the third power over space to the third power, and so on and so forth. And if you'd like a more thorough rundown of how the postulates work and how he plugs them in and derives a theoretical universe from them, you probably want to take a look at one of my first 474 videos on the subject, where I go into it in a little bit of detail. Even more detail you could get from watching my 15 videos on the outline of the deductive development of the reciprocal system, which is a paper that Larson gave many years ago. Larson died back in 1990, leaving behind a great theory, but incomplete, and with a few rough edges and mistakes. And so it's been a struggle to kind of keep it afloat. A lot of great work was done by Drs. KVK Nehru and Dr. Bruce Perrett in order to kind of reevaluate and reformulate some of the difficulties that Larson had and extending it into other areas. But still progress is slow. And so that's hopefully where I come in to revive some interest in the reciprocal system and get some people working on it, because I believe that ultimately when we get to the 22nd, 23rd, I don't know, century, this will be the foundation for all learning. But it hasn't been fleshed out enough for people to figure that out yet. But I think you can get a good idea by looking at some of his work here, because he is able to formulate a theoretical universe that mirrors the empirical universe of the modern scientists. So he's able to recreate, in many cases, their scientific tables just from theory. So you got to figure that he's onto something, even though, as he admitted, whether he applies his theory correctly in every situation, is a different matter as whether the theory itself is correct. Okay, well, we are in the middle of chapter 26 on atom building, and let's get started right here. Okay, atom building in intergalactic space is slow because of the low density of matter, but the amount of time spent in this stage is so long that there is sufficient opportunity for production of a finite quantity of all of the 117 possible elements in proportions determined by the relative probabilities. After this initial period, the existing matter is increasingly concentrated into large aggregates. This speeds up the atom building, but meanwhile there are processes in operation that destroy some of the heavier elements. A significant aspect of the theoretical findings reported in this and the immediately preceding chapters is the important role of the massless particles, entities which, with the exception of the photon and the neutrino, are not recognized by conventional science. As brought out in the discussion earlier in this chapter, the characteristic feature of these particles is that they have no capability of independent motion and are therefore stationary in the natural system of reference. It follows that they are moving at unit speed, the speed of light, in the context of the conventional spatial reference system. According to our findings, there are three categories of material particles: combinations of motions without enough rotational displacement to form the atomic type of structure. These are 1, massless particles, 2, similar particles that have acquired mass, and 3, particles with structures intermediate between those of class 2 and the full atomic structure. This table lists the subatomic particles of the material sector. The mass 1 hydrogen isotope is included in this list because of its intermediate type of structure. Although it is generally regarded as a full-scale atom, electric charges that may be present are not shown, except in the case of the one-dimensional charge particles, where they provide the rotational vibration that brings these particles into the gravitationally bound system. Charges applied to other particles in the list have no significant effect on the phenomena now being considered. So, his table, subatomic particles, starting with the massless particles, we've got the photon, and then we have, which is not notated. And then we have M0-0-0, the rotational base. We have M0-0-1, the electron. And then we have the charged neutrino, M1/2-1/2-1. We have the positron, M0-0-1. We have the neutrino, again, M1/2-1/2-1. We have the massless neutron, M1/2-1/2-0. Okay, so those are the massless particles. Now he's got the particles with mass. That is the charged electron, M0-0-1, -1, and the charged positron, positive, M0-0-1. And then we also have the proton, M1-1-1. And then we have the intermediate systems, where there are two components. The compound neutron being M1-1-1, along with C, -1/2-1/2-1. So those two together are the compound neutron. And then the mass 1 hydrogen isotope is a combination of M1-1-1 and M1/2-1/2-1, -1. The mass 1 hydrogen isotope. Okay. An exact duplicate of Table 36 list exists in the cosmic sector with the speed displacements inverted. In this case, the particles are built on the cosmic rotational base, represented as C0-0-0, rather than the material base M0-0-0. The particles not listed in Table 35 that the physicists claim to have discovered, mesons, etc., are combinations of the cosmic type, either particles from the cosmic subatomic list or full-sized cosmic atoms, where the presumed discoveries are authentic. It is even possible that some of the events of extremely short duration attributed to transient particles may be originated by cosmic chemical compounds. Recognition of the place of the massless particles in the evolutionary pattern of matter is one of the advances in understanding that has given us the present consistent and apparently correct explanation of the transition from cosmic to material and vice versa. The 1959 publication identified the cyclic nature of the universe and gave an account of the manner in which the transitions between sectors take place. At that time, however, the existence of the massless particles had not yet been discovered theoretically, and the particle now identified as the compound neutron was thought to be the intermediary by means of which intersector transfer is accomplished. When it was finally realized that the theory requires the existence of a massless neutron, the door to a new understanding of the transition process was opened. It then became evident that the transition is not directly from cosmic to material, but from cosmic, moving inward in time, to neutral, no motion relative to the natural reference system, and then to material, moving inward in space. This finding revolutionized our concept of the position of the massless particles in the physical picture. It can now be seen that these particles, the neutrino, known to conventional science, the massless electron and massless positron, previously identified as the moving particles in electric currents, the massless neutron, the rotational base, and the gravitationally charged neutrino, discovered theoretically, are the constituents of a hitherto unknown subdivision of physical existence, a neutral state of the basic units of matter, intermediate between the states of the cosmic and material sector. Inasmuch as the atom-building process operates by means of successive additions of single units, the relative proportions of the various elements in a material aggregate are directly related to the age of the matter and inversely related to the atomic number. However, there are a number of collateral factors that modify the basic relations. As we have seen, production of the mass 1 isotope of hydrogen is a relatively simple matter, involving nothing more than a union of two simple particles. The next step is more difficult because it requires the formation of a double system in which there are effective rotational displacements in both components. The great majority of the material atoms are therefore still in the hydrogen stage. The first full double system, helium, atomic number 2, is in second place, as would be expected. Beyond this level, atomic rotation becomes more complex, and factors other than the required number of additions of mass units introduce numerous irregularities into what would otherwise be a regular decrease of abundance with atomic number. Evidently, a single addition to the atomic rotation introduces a degree of asymmetry that decreases stability, as the even-numbered elements are generally more abundant than the odd-numbered elements. For instance, the 10 most abundant elements beyond hydrogen in the Earth's crust include 7 even-numbered elements and only 3 with odd atomic numbers. The zone of isotopic stability is likewise wider in the even-numbered than in the odd-numbered elements, as would be expected if they are inherently more stable. Many of the odd-numbered group have only one stable isotope, and there are 5 within the 117 element range of the terrestrial environment that have no stable isotope at all in that environment. On the other hand, no even-numbered element other than beryllium has less than 2 stable isotopes. The same kind of symmetry effect can be seen in the first additions of rotation in the magnetic dimensions. The positive elements of group 2A, lithium, beryllium, and boron, are relatively scarce, while the corresponding members of group 2B, sodium, magnesium, and aluminum, are relatively abundant. At higher levels, this effect is not apparent, probably because the successive additions to these heavier elements are smaller in proportion to the total mass, while the effects of other factors become more significant. One of the features of the rotational patterns of the elements that introduces variations in their susceptibility to the addition of mass and corresponding variations in the proportions in which the different elements occur in material aggregates is the change in magnetic rotation that takes place at the midpoint of each rotational group. For example, let us again consider the 2B group of elements. The first three of these elements are formed by successive additions of positive electric displacement to the 2-2 magnetic rotation. Silicon, the next element, is produced by a similar addition, and the probability of its formation does not differ materially from that of the three preceding elements. Another such addition, however, would bring the speed displacement to 2-2-5, which is unstable, in order to form the stable equivalent of 3-2-3. The magnetic displacement must be increased by 1 unit in one dimension. The probability of accomplishing this result is considerably lower than that of merely adding one electric displacement unit, and the step from silicon to phosphorus is consequently more difficult than the additions immediately preceding. The total amount of silicon in existence therefore builds up to the point where the lower probability of the next addition reaction is offset by the larger number of silicon atoms available to participate in the reaction. As a result, silicon should theoretically be one of the most abundant of the post-helium elements. The same considerations should apply to the elements at the midpoints of the other rotational groups when the consideration is given to the general decrease in abundance that takes place as the atomic number increases. As we will see in Volume 3, there are reasons to believe that the composition of ordinary matter at the end of the first phase of its existence in the material sector, the dust cloud phase, conforms to these theoretical expectations. However, the abundances of the various elements in the region accessible to direct observation, a region in a later stage of development, give us a different picture. The total heavy element content does increase with the age of the matter. A representative evaluation finds the percentage of elements heavier than helium ranging from 0.3 in the globular clusters, theoretically the youngest stellar aggregates that are observable, to 4.0 in the population 1 stars and interstellar dust in the solar neighborhood, theoretically the oldest matter within convenient observational range. These are approximations, of course, but the general trend is clear. The peaks in the abundance curve that should theoretically exist at the midpoints of the rotational groups also make their appearance at the appropriate points in the lower groups of elements. The situation with respect to carbon is somewhat uncertain because the observations are conflicting, but silicon is relatively abundant compared to the neighboring elements, as it theoretically should be. And iron, the predominant member of the trio of elements at the midpoint of group 3A, is almost as abundant as silicon. But when we turn to the corresponding members of the 3B group, ruthenium, rhodium, and palladium, we find a totally different situation. Instead of being relatively abundant, as would be expected from their position in the atomic series just ahead of another increase in the magnetic displacement, these elements are rare. This does not necessarily mean that the relative probability of effect due to the magnetic displacement step is absent, as all of the neighboring elements are likewise rare. In fact, all elements beyond the iron-nickel group exist only in comparatively minute quantities. Estimates indicate that the combined amount of all of these elements in existence is less than 1% of the existing amount of iron. It does not appear possible to explain the relative abundances in terms of the probability concept alone. A fairly substantial decrease in abundance compared to iron would be in order if the age of the local system were such as to put the peak of probability somewhere in the vicinity of iron. But this should still leave the ruthenium group among the relatively common elements. The nearly complete elimination of the heavy elements, including this group, which should theoretically be quite plentiful, requires the existence of some additional factor, either 1, an almost insurmountable obstacle to the formation of elements beyond the iron group, or 2, a process that destroys these elements after they are produced. There is no indication of the existence of any serious obstacle that interferes with the formation of the heavy elements. So far as we can determine, the atom building process is just as applicable to the heavy elements as to the light ones. The building of heavy elements is endothermic, but this should not be a serious obstacle, as in any event it does not apply below group 4A, and therefore has no bearing on the scarcity of the 3B and lower division 3A elements. The peculiar distribution of abundances therefore seems to require the existence of a destructive process that prevents the accumulation of any substantial quantities of the elements heavier than the iron group, even though they are produced in the normal amounts. We have already seen in Chapter 17 that such a process exists. This process will be examined in detail in Volume 3, The Universe of Motion on Astronomy, where it will be shown that the theoretical results of the process are in full agreement with the observed distribution of the abundances of the elements. The entire atom building process described in this chapter is duplicated in the cosmic sector, with space and time interchanged. Here, the inverse mass is added to move the elements up the cosmic atomic series. Okay, that is the end of chapter 26, atom building. And Larson is kind of setting the stage for his book on astronomy, Universe of Motion, there, where he gets into the reason why there are very few elements beyond the iron-nickel group. We are up to the final chapter of this book, which we've been laboring on for a very long time, but not so much just because it's on chemistry and that we need to learn chemistry, but to see how Larson's thought process works and how he takes his postulates and applies them, so that we can also do the same in our own field of study. That's the beauty of the reciprocal system, is that it is a generalized theory, so that if you understand how it operates, then you can use it to apply it to whatever subject you like. And so when we can take a look at how Larson applies his theory to various subjects, we can glean how to apply it to the subjects that we'd like to apply it to. And again, I believe that in the future, distant or, really could be close by, that science will be not science, just science, but all curriculum, our whole academic curriculum, from the liberal arts to the sciences, the religion, and every possible form of understanding will be founded on the reciprocal system of theory. Now, there might be other ways of knowing, other theories that are appended to that, but I believe that the reciprocal system will be the foundation. And so we might as well learn it now, get in on the ground floor, and that way by the time everybody else discovers how important this is, you'll already be, a leg up, and you will be able to parlay your, your knowledge and expertise in an area where there is great demand. As of right now, there is practically no demand, but, this is kind of like investing. You try to see the trends, you try to see what's coming, and then you invest in your future. And I believe that the future is very bright for the human race because, for one reason is because of the potential of the reciprocal system of theory. So hopefully you'll delve into some of my other works on this subject, my other videos, and get yourself a working knowledge of the reciprocal system. Dive into Larson's work and work of some of his associates, and do it with an open mind, not to debunk everything right off the bat, but to suspend disbelief if he says something that flies in the face of what you already believe. Be able to, hold multiple points of view in your head at the same time, and just have an open mind. Okay, thanks for tuning in today, and we'll be back with the beginning of the final chapter, Mass and Energy, in Basic Properties of Matter, tomorrow. Thanks for tuning in. Have a great